that we have discussed about the focal distance and the latest rectum, let us see some of the properties of focal chord. The first property that is written is, if the chord joining P point and Q point, which are AT1 square, 2AT1, and the Q point is AT2 square, 2AT2, which are the extremities of your focal chord, then the relationship between T1 and T2 is given by T1 into T2 is equal to -1, which is a very important property. And because of this property, you can say that if one extremity of the focal chord is suppose P AT square, 2AT, then the second extremity of that focal chord will be Q into A by T square, minus 2A by T. You can write the extremities of the focal chord in this way. The second property is that if the point P is AT square, 2AT, then the length of the focal chord PQ will become A into T plus 1 by T whole square. This is the length of the focal chord PQ, where P point is this, so the Q point will become this. Third point says that the length of the focal chord which makes an angle theta with the positive direction of x-axis, that means if it is making an angle theta with the positive direction of x-axis, that means the slope of this focal chord is equal to tan theta. Okay, then the length of the focal chord in terms of theta is given by 4a cosec square theta. So if you know the angle, you will use the formula 4a cosec square theta. If you know the points P and Q, then you will use the length of the focal chord as A into T plus 1 by T whole square. Coming to the next property, which says that the semi-latest rectum is the harmonic mean of SP and SQ, where P and Q are the extremities of the focal chord. If S is the focus and P and Q are the extremities of your focal chord, then the semi-latest rectum is the harmonic mean of SP and SQ. In mathematical terms, you can write this as 1 by SP plus 1 by SQ is equal to 1 by A. This is the relationship between the distance SP and SQ if A is known to you. The fifth property says that the circle described on focal length as diameter touches the tangent at vertex. If you take the focal length as the diameter and make a circle through it, then you will see that that circle will touch the tangent at vertex. I can show you a few things over here. That suppose this is your parabola, then this line is known as the tangent at vertex. This is your tangent at vertex. If you take, suppose this is your S focus and this is your point P, okay, then this PS is the focal length. If you take PS as the diameter and draw a circle, then it will definitely touch your tangent at vertex. That means tangent at vertex becomes the tangent to this circle also. This is what the fifth point is saying. Coming to the sixth point, the sixth point says that the circle described on focal chord as diameter. Now in this case, what do you have to do? You have to take the whole focal chord as diameter. So suppose this is your focal chord, this is your S point, and these two are the extremities of your focal chord, which are P and Q. And this is suppose your directrix. Then it is saying that if you take this as the diameter and draw a circle, this is suppose the circle that you draw, then it will touch the directrix. That means directrix becomes the tangent to this circle. Fifth and the sixth point are very important. That if you take focal length as diameter and draw a circle, it touches the tangent at vertex. And if you take the whole focal chord as diameter, it touches the directrix.